Today we're going to be going over Leetcode problem 876, middle of the linked list. In this problem we are given the head of a singly linked list and we need to return the node in the middle of that linked list. If there are an even number of nodes, we should return the second middle node. We can scroll down here and see that the size of the linked list will be between 1 and 100 inclusive. So the most straightforward approach, since we know the size of the linked list won't be greater than 100, will be to loop through the entire linked list and copy it over into an array. Because lookups in an array are O of 1, we can then look up the middlemost node in the array easily. This implementation has O of n runtime and O of n space complexity as well. We'll code it up and see how it looks, and then discuss a more optimal solution. First, we will need to create our array of list nodes, which will be of size 100, our starting list node, which will be equal to head, and an int index that will be used in our loop as we populate the array. Then, while current node is not null, we add it to the next spot in the array, set current node to currentNode.next, and increment the index. Then, when we are done with this loop, all we have to do is return the middle element of the array. If the array has an odd number of list nodes, this will return the middle list node, while if it has an even number, this will return the second middle list node. We click submit and see our submission was accepted. A common practice that happens in coding interviews is for you to talk through and code up your initial solution, and then you get the dreaded question from your interviewer. Now, how can you improve this? When this happens, it's important not to panic and to logically think through your solution and see where something might be optimized, both time or space-wise. In our example, we already have an O of n runtime, which we're not going to be able to beat, because we know no matter what, we have to go through at least half of the nodes of the linked list to get to the middle node. That means we can probably improve our space complexity. A common technique when solving linked list problems is to use a fast, slow pointer approach. In this approach, we will use 2 pointers. Every time we increment the slow pointer once, we will increment the fast pointer 2 times. This way, when the fast pointer reaches the end of the linked list, we know the slow pointer will be at the middle node, so that's the one we need to return. In terms of implementation, first we need to initialize 2 list nodes to head, fast and slow. Then, while fast and fast.next aren't null, we want to set fast to fast.next.next and slow to slow.next. When we reach the end of this loop, fast will be at the last list node in the list, and slow will be at the middle list node in the list. We go ahead and click submit, and we see that our submission was successful. The runtime of this algorithm is O of n as well. However, the space complexity is O of 1. This is obviously much better and is more optimal than our first solution. The important thing to remember when your interviewer asks you to improve your solution is first to identify the bottleneck in your code. For us, it was the array of list nodes we were creating. Then you want to think of ways you can address that bottleneck and improve the time and/or space complexity of your solution. That'll do it for today's problem, so be sure to like and subscribe for more, as well as let me know what problems you all want to see down below in the comments.